Hi, welcome back to Moose and Chemistry, Chemical Equation Balancing Lesson number 20. Balancing chemical equations doesn't have to be hard. It can actually be really super duper easy. Let me show you how. Okay, let's look at our compounds first. We have iron chloride, and that's a reactant because it's on the left side of the equation. We have a ammonium hydroxide. That is also reactant because it's on the left side of the equation. On our product side of the equation, we have iron hydroxide. So there's a product there. And we have ammonium chloride right here, and that's also a product. So far, that's easy, right? You guys can do that. So how do we make this really super duper easy? We draw a table. Now keeping this table will help you keep everything perfectly straight, even though drawing the table may not look that straight. So let's do this. First element I see going from left to right is iron. So we'll write Fe right here. And we have one of those. The second element I see is chlorine. So let's draw a line right there. Oh, look, we have a subscript of 3. That means we have 3 chlorines. The next element we see here is, of course, nitrogen. So let's draw a line here. We have 1 nitrogen. The next element that we have, of course, is going to be hydrogen. Now you see we have 4 hydrogens, but we have a little bit more than that. We've got this hydrogen here. So 4 plus 1 is 5. See how easy that was? Man, this stuff is so easy. All right, now we have oxygen. We've got one of those. Now notice that our right side of our equation is not in the same order as our left. But I will tell you a little secret. Always make the right look like the left. Because when you read the numbers, it's easier to see them in the same order. It's very, very important to do that. So, regardless of whatever I see on the right, I'm going to write it like this. Fe, Cl, nitrogen, that's right, hydrogen, and of course oxygen. All right, we have 1 iron. Okay. Oh, look at this 3 right there. Now, I'm going to erase something here real quick because I need some space. And I want to show you something about that 3. That 3 is going to multiply to the H, and it's also going to multiply to the O. So that means I've got 3 times 1 is 3 H's. But look, we have 4 H's here too. See that? So 3 plus 4 is 7 H's. All right. Look at our nitrogens. We only have one of those, so we're good there. Our chlorines, we have one of those there. Let's look at our oxygens. We have 3, because 3 times 1 is 3. Now, 1, 3, 1, 5, 1 does not look like 1, 1, 1, 7, 3. We want those numbers to be the exact same. All right, so we need the eraser again to clean up things a little bit so we can see some work that we're about ready to do. So here comes the fun part. And I'm going to go pretty slow on this so that you can follow along with me. All right, so chlorine here, we got 1 of those, and chlorine here, we got 3 of those. So we want to change this to 3 chlorines. You can't write a 3 below the chlorine. You can't add subscripts, but you can do something called a coefficient. Coefficient goes in front of the compound, so we put a 3 there. That gives me 3 here. Now when we put that 3 in front of that changes my nitrogen to 3. That changes my hydrogens to 12 because 3 times 4 is 12, but you got to add these 3 over here, remember? So that's going to give me 15 hydrogens. And our chlorines are 3, of course. Now, so we got 1, 3, 3, 15, 3. Well, if we change our nitrogens to 3, we have to change our nitrogens over here to 3. So we have to put a 3 in front of the coefficient there. That was simple. That gives me 3. 3 times 4 is 12. And then 3 times 1 is 3. So 12 plus 3 is 15. Pretty cool, huh? And our oxygens, 3 times 1 is 3. 1, 3, 3, 15, 3. See that? 1, 3, 3, 15, 3. Hey, that's it. We're all done. See how easy that was? If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry.